Welcome to today's lesson, and we are looking at Iupac nomenclature of complex ion. All right, Jamb loves repeating this question. If you need any material, especially last-minute preparation plan or the file containing the most repeated questions by Jamb in physics, chemistry, and biology, please send me a message on WhatsApp. Or you want me to just prepare you for your Jamb UTME, let me coach you within this short period of time. All road leads to my what? My WhatsApp number. All right. So the question we have in front of us here, Jamb must repeat question 1. It reads, "What is the Iupac name of the complex CrONH3 for chloro 2 and positive? It can't be for positive. See all the what? All the options. See all the options be all these ones. No time to be reading option. Okay. So what do? We have to break down this complex structure here. We were given CR. We were given to know all the elements and compounds in it. All right. For Cl, which is chloro. This one is almost the same with calculation of normal oxidation number, but you just have small nuance in it. Just small little difference in it. All right. So the first thing to do is to know the compounds and the elements present in this compound. All right. So what do? Remember, we are looking for we have to know the oxidation state of chromium here. This is chromium. Cr is what? Chromium. Chromium. Okay, chromium. NH3 is what? Amine. NH3 is ammonia, but here, because we are doing nomenclature, it is amine. It is going to be referred to as amine. All right. Then this 4 we have here shows that it's times 4. Look at it, times 4, which is what? Tetra. Okay, 4 will give us what? Tetra. It's called tetra. That's why we're going to represent it as tetra. Okay. Then let's look at prefixes. Okay, prefixes. We already discussed what prefixes are. All right. We have prefixes like mono, which means 1. It can be indicated as mono, or they will not even put the mono at all, because if you say pen, get me a pen, and get me 1 pen, is the same thing. Okay, get me pen, get me 1 pen, is the same thing. Okay, sometimes they will not just put mono at all. Okay, di means 2, tri means 3. You have tetra. Tetra, we already talked about this. Tetra means 4. All right. So this is like the basics. Okay, remember that all these, okay, like this one, NH3, amine, and chromium, all these are called ligands. Okay, what are ligands? Ligands are ions or element or compound bonded to a parent compound. Okay, bonded to another element. Okay, that's ligand. So since we have tetra here and we have amine here, let's quickly call that tetraamine. Okay, let's quickly call that tetraamine. All right. So remember, we have chloro here. Okay, and the chloro we have here is 2. Can you see? The chloro we have here is 2. So let's quickly call that dichloro. Okay, dichloro. 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 All right, we call that dichloro. So we already have these 2 as part of the name. Okay, so what do we do next? We are almost done naming this. All right, the only thing that we haven't named here is this chromium. And we can't name this chromium because we don't have the oxidation states of this chromium. We have to calculate the oxidation number of this chromium. But while calculating oxidation number in complex ion or in complex compound like this, you have to bear something in mind. You have to bear something in mind. The charge. If there's any charge here, you are going to use this charge. Okay? You are going to identify it as the number. That's a normal calculation of normal oxidation state in inorganic chemistry. Is seen that the sum of all oxidation number equal to 0. You will do everything equal to 0. But here you are doing it equal to the number of charge, which is always represented here. Sometimes you don't see any charge here. That's you do it equal to 0. If you don't see any charge here, any number of charge here, do it equal to 0. Okay, since we have number of charge, we just have 1 positive. That's 1 plus. That will be equal to what? Plus 1. Okay. So let's now calculate the oxidation state of chromium. Okay. So find oxidation what? State of what? State of chromium. Okay. Looking to find this oxidation state of chromium, we apply the formula now. Everything with the now we go to solvent. Okay. Taking chromium as its normal Cr plus. Okay. Why is it plus? Because this NH4, okay, is plus. The state of this NH3 is what? What is the oxidation state of amine here? The oxidation state of amine here is what? Is 0. Okay. Because amine is in a neutral state. In fact, let me just write it. NH3 equal to what? 0. Okay? Equal to 0. Because it is what? It's in its neutral state. Because it's neutral. Neutral. Okay? So what do we have again? We have chlorine or chloro. Chlorine. Chlorine ion. Because here an ion will be. Chlorine ion is equal to -1. okay, because it's equal to the number of charge. We just have just minus one charge there, okay, equal to -1. So looking at this, we continue with this. What do we have here next? We have NH3, which is 0, neutral, okay. We are going to put that in what? In bracket 0, bracket close. What do we have beside it? 4, meaning that it's times 4. So we put it times 4, okay, times 4. Then what do we have next again? We have chlorine. And what is chlorine? The charge number of chlorine is -1, okay, -1. We put it in bracket to -1 to avoid confusion. And we have what? 2, okay, 2. We have what? 2, and 2 is the same thing as +2, okay. As simple as that, ABCD. It will now be equal to what? The sum of all the oxidation, which is what? +1, okay. So to simplify this, we are going to open all the brackets. 4 times 0, this one is 0, plus 2 times -1 is what? Is now going to, we are now going to have 2 here. So bringing everything down, we are now going to have C arrow, 0. This one has 0. We don't need to put them. So here we will get +2. So 2 times 1 is 2, okay. Plus times minus is minus. So we now have -2, okay, is equal to +1, sum of all, sum of the charges, +1. So what do? We collect like terms. To find the answer, if we collect like terms, I bring chromium on this side, 1 come this side, it becomes minus. So -1 minus 2 is equal to minus chromium, okay. -1 minus 2 will give us what? -3, equal to minus chromium, okay. Then we switch the position, we inverse it, and we are now going to have chromium equal to +3. So this is the oxidation state of chromium inside here. So what do we do now? We rearrange it following the Iupac rule to get the name of this compound. Remember, alphabetical order, okay? The ion of the metal and the overall charge, everything. Remember, this metal is in its ionic state. It's a complex ion. Everything here did the ionic state. So for us to rearrange, we are going to write the Iupac name following the rule, ligands first, following alphabetical order. What's the ligands? All these one are the ligands, okay? Tetraamine, dichloro. The tetra no join, now the A and the C, all this tetra, leave all this tetra, the prefix no join. The alphabetical order applies to the ligand itself, okay? Not this prefix that we are using here, okay? This amine, A and chloro. So which one will come first? Is it amine or chloro? It's amine that will come first. So we are going to say tetraamine, okay? Tetraamine. Then the next is what? Chloro. Dichloro. Okay, what's now the next again? Chromium. Chromium is the next. Chromium. Okay, so the metallic ion, chromium. Let's put it here. Chromium. How many ion? This is the ion we calculated. The oxidation state 3. 1, 2, 3. Remember, you represent the number with what? Roman figure. Okay, Roman numeral. 3 ion. Okay, so this is the name of this compound. So among the options, pick the correct option and drop it in the comment section. Now let's look at some simple rules pertaining to naming complexes. Okay, complex ion. Okay, complex compound, complex salts. All right. So let's look at common ligands. Okay, common ligand name. Let's say ligand name. Okay, what are they? The ones you are likely going to encounter. Okay, NH3. This one is called amine. Okay, if you see H2O, this one is called aqua, water. If you see Cl, this one is called what? Chloro. If you see OH, this one is called what? Hydroxo. If you see Cn, negative, this one is known as cyano. Okay, if you see CO, this one is known as carbonyl. If you see NO2, this one is known as nitrito. If you see En, this one is known as ethylene diamine. Diamine. All right. So these are the common ones. Okay, this one not too common. This last one is not too common. Okay, so these are the common ligand name. Okay, remember that sum of all oxidation equal to overall charge. Equal to what? Overall charge. Okay, so neutral ligands include, that's the ones that will go with 0. Neutral ligands include, you have NH3, which is the amine. You have Then you have CO2. No, not CO2. Then you have CO, bracket close. CO is called what? Carbonyl. All right, CO, carbonyl. All these are the what? Are the neutral. They are equal to 0. Okay, equal to 0-ish. Anionic ligands, that's their negatively charged. Anionic ligands, okay, they include Cl, that's the negatively charged, with just one charge, -1. Okay, OH, which is the what? The hydroxyl, and you have the Cn. All of them are 1 charge. All of them equal to -1. That's their oxidation state. Okay, then you also have free elements. Okay, there are free elements. This one is normal oxidation now. Free elements. Free elements equal to 0. You also have oxygen. Oxygen is usually -2. Okay, oxygen usually -2. But sometimes in some other compound, you can see it as like in peroxide. In peroxide, it goes with -1. So in peroxide, it carries -1. Okay, hydrogen is usually +1. Okay, hydrogen is usually +1. Which other one again? Okay, the formula for electron transfer. The formula for electron transfer is what? Change in oxidation. Change in oxidation number. Change in oxidation number times number of atoms, which is equal to what? We give you electron transfer. Electron transferred. Okay, so change the oxidation number times number of atoms, we give it what? The electron transfer. So if they ask you what is the electron transfer, you just say change in oxidation number times, that's the two oxidation number, you -1 from 1, times the number of atoms, and you get electron transferred. All right, for example, e.g., for example, you have let's say you have manganese, okay, manganese ion, tetraoxomanganate 7 ion. Then you have it ionizes to form manganese 2 ion. All right, so when this happens, how do you get the electron transfer during this reaction? If they ask you what's the electron transfer during this reaction, did you notice that the oxidation state, okay, of manganese here reduced from 7? It's reduced from +7 to what? To, look at what we have here, +2. It reduced from +7 to +2. Manganese here. And how many electron was transferred? Because it reduced from +7, remember, is tetraoxomanganate 7 ion. Here is manganese 2 ion. Okay, so since it reduced from 7 to 2, which means that what? You minus what? The change in oxidation number times atom. Okay, so you change in oxidation number is what? Is 5. So electron transfer is 5. 7 minus 2 equal to 5. So it is what? 5 electrons gained. Okay, 5 electrons gained for tetraoxomanganate 7 ion to what? Be reduced to manganese 2 ion. So tetraoxomanganate 7 ion lost 5 electrons to form manganese 2 ion. So manganese 2 ion accepted 5 electrons to be reduced to manganese 2 ion. Okay, so tetraoxomanganate 7 ion accepted how many electrons? It gained 5 electrons to be reduced to what? Manganese 2 ion. All right, that's that for that. Chicken out, very easy.